So in the previous video, we found the greatest common factor of two numbers, all right? In this video, we're going to find the greatest common factor between two monomials, okay, or algebraic expressions. So we're going to find the GCF for monomial expressions. We're going to do a couple things, okay? We want to find the GCF of the numeric factor, okay, the coefficient. So I want to find the greatest common factor of the numbers. Then I want to find the greatest common factor of the variable expressions. And to do that, I'm going to break these variables down, okay, as products of the individual variables. Again, we're going to see which of the variables or how many of those variables we have in common. Once we've done that, then we're going to kind of mash it all together into the product of the common factors, okay? So we're going to start out with a pretty easy one here. So 5x cubed, 5 is already a prime number, so numerically that can't be broken down anymore. But x cubed is going to be the product of three different x's, okay? So I want to break it down like that, okay? 15 is broken down as 3 times 5, and then x squared is the product of two x's, okay? So what we want to look for is the expressions, the numbers or the variables that these have in common, okay? So if you'll notice, I left a little space here. If you'll see what they have in common, they both have a 5 in common, and they've got these, the product of these two x's here, okay? So my GCF is going to be this product right here, okay? Or you can think of it as this product right here, 5 times x times x. But either way, 5x squared, 5 times x, is going to be my GCF, okay? All right. Again, we're going to use this concept a lot, so make sure you get this down, all right? Number 4, we want to factor 4x squared and then y. So 4x squared y, we want to break it down into into prime factors. So 4 is 2 times 2, x squared is x times x, and then y. Notice I left a little space here. You'll see y in just a second, okay? 10 is going to be 5 times 2. X to the fourth is x times x times x times x, and y squared is y times y, all right? So what do they have in common? All right, well, the first thing they have in common is this 2. Then they have 2 of these x's in common, all right? And then they have 1 y in common. So my GCF is going to be the product of these four values, 2 times x times x times y, 2 times x times x times y. All right, so my GCF here is going to be 2. X times x is x squared, and then I've only got this one y, so y to the first. So my GCF is 2x squared y. Okay, so that's the greatest monomial expression that both of these are divisible by. Okay, and number 5, this is the most complex one we're going to do here. We've got 3 different monomials here, both with a constant coefficient here greater than 1, both with x's to multiple powers, and both with y's to multiple powers, okay? So let's think of 30. The prime factorization for 30 is 2 times 3 times 5, okay? X to the fifth is x times x times x times x times x. Notice there's 5 x's there. Y cubed is broken down with these 3 y's, okay? 6, prime factorization, 2 times 3, x to the fourth. Notice we've got 4 x's here, y squared, we've got the 2 y's there. And then 12, prime factorization, 2 times 2 times 3, x cubed, means we have 3 x's there, y to the fourth, we have the 4 y's there, okay? So let's look at what they have in common, okay? And I'm going to highlight these in red because I couldn't do all the circles here. So they've got 1, 2 in common. They've got 1, 3 in common. They've got 3 different x's in common, okay? And then they've got 2 y's in common. So everything that's in red on any of these lines, I'm going to multiply together to get my GCF, okay? So the number is 2 times 3, which is 6. X times x times x is x cubed, and y times y is y squared. So my GCF is going to be 6x cubed y squared, okay? So that's how you're going to find the GCF for monomial expressions, okay? And again, we're just going to keep expanding on this concept of GCF, so make sure you get this down.